Hello everyone, welcome to the Unhandled Exception podcast. I'm Dan Clark and today I'm joined by Patrick Smacchia to chat all about NDepend. And I believe Patrick is joining us all the way from the island of Mauritius. So welcome to the show, Patrick. Thank you for joining us.
Hi Dan, thanks for the opportunity to talk here.
Oh, you're most welcome. I'm really looking forward to this one. So could you give us a quick intro into your background? And am I right in thinking that you've also authored a book?
Yes, so I'm Patrick Smacchia. I'm sure you already understood that I'm from France.
Yes.
Okay, so I'm 45, but I started coding when I was 10. So that's more than 3 decades I'm in coding. So I did a lot of C++ professionally. And then when .NET arrived in 2002, around 2002, I had the opportunity to write a book about the early day of .NET for O'Reilly, the edition O'Reilly, which was quite successful. It was really a great opportunity to learn about all the goodies you can have in the platform, because .NET is very special because not only at the beginning it came with many goodies, but for almost 2 decades now, it never ceased to improve and improve and improve. Even the next version, .NET 6, will be absolutely amazing. So many new stuff, especially concerning performances. So it's really a joy to be a .NET expert these days. And I have to say that maybe except things like Silverlight, I have to say that Microsoft never disappointed about .NET improvement and evolution. And so that's great. So after writing the book, what happened is that my name was a little bit famous in terms of .NET expertise. A lot of large company like banks and other large company with tons of legacy started to hire me as a consultant for teaching them and for teaching the team .NET, but also for analyzing the code, for assessing the code they have, what they can do to improve. So what happened is that I started writing a tool, which actually was NDepend since the beginning in 2004. And so it was a very small tool, open source tool, and it was based on a Robert Cecil Martin principle. Okay, so I'm not sure if you heard about it, but Robert Cecil Martin, also known as Uncle Bob, is quite famous for having coined many good concepts, all the solid principles, but also some other concept about what is a component and how components should interact, and dependency inversion and stuff like that. So Robert Martin wrote a lot about that, and from all this writing, you can infer some code metrics, meaning that you can obtain some numbers from analyzing some codes. And then from some numbers, you can somehow assess if a code base is good or bad and what can be improved. Okay, so I was very interested into all this code metric and code quality stuff. So this is how I started NDepend. And just to have a tool that I can go to my clients, just scan their legacy and try to obtain some interesting stuff automatically to make sure that I can provide as much value as possible from my consulting time there. And what happened is that NDepend as open source was a lot. I can see that it was a lot of guys were downloading it. Okay, so there was a lot of interest about it. And after a few years, I saw the opportunity to make it commercial. And this is how NDepend becomes the tool we know now, which is now quite a solid tool with many features and many active users worldwide. So this is how it all started.
That's such a great story where you're a consultant and you've seen a problem and you've built something for yourself, and then that's actually grown. Rather than it being a business opportunity, you've started off as just solving a problem that you're having, and then that's grown and you've seen interest. That's really, really good. And I've worked at quite a lot of companies now, and quite a lot of them, when the topic of analyzing the source code, looking at the complexity, NDepend seems to come up an awful lot. And it's one of those things where So I'm quite embarrassed here because knowing me, this is the kind of tool I would really use quite heavily in the past. And I don't know why I have. I honestly don't know why I haven't, because as I say, past companies, there's always been someone at the company that's been an NDepend expert and has like pulled out and created these amazing diagrams. And normally that's something that I would jump on. And I don't know why I haven't. So this week, because obviously we knew we were doing the podcast, I've downloaded the trial. I've been playing around with one of my projects. So it's really nice having all the lots of suggestions. I'm embarrassed to how many suggestions there are in my code, but it's nice seeing all those and seeing all the diagrams. So it's definitely something I'm going to be looking at moving forward for like most of my projects, really.
Yeah, so as you said, NDepend can provide a lot of suggestions in a lot of ways. So as I mentioned earlier, there are some metrics, so you can have a lot of numbers from NDepend, like the size of your code or the complexity of your code. And it also comes with the rule system. So from the rule system, you can have some issues. Okay, and then from issues you can decide if it worth fixing it or not. And also NDepend can help with it comes with several diagrams. So there are several ways to visualize your code, like the classic dependency graph, which I believe is more powerful in NDepend, more detailed because it's really one of its core features. You also have some dependency matrix and also some code metrics visualization through a colored tree map. And also it's a reporting tool that can produce some reports from your CI/CD build system, and also from your Azure DevOps system. So very concretely, NDepend comes with three flavors, which is first a Visual Studio extension. So NDepend can run inside Visual Studio and can provide all the goodies from inside Visual Studio. This is the developer SKU. The developer SKU also support all features you get into Visual Studio extension with Visual NDepend.exe as a standalone. So if you are very, very careful for your Visual Studio performance, which actually NDepend doesn't impair Visual Studio performance like other extension that I will name, but I understand if some guys really prefer to have extra features outside the ED. So with NDepend it's possible. So this is the SKU developer. Then you have the SKU build machine, which just lets you invoke NDepend.console, which is a classic console with command line argument. And from there, you can generate some reports that you can share with the team. Included with the SKU, there is also an API that you can target with your own C# program. So basically, you can automatize everything in NDepend thanks to the API. And finally, there is the third SKU, which is the Azure DevOps extension, where it's very convenient to have also a lot of information also into your Azure DevOps as a Azure DevOps app, the NDepend Azure DevOps apps. So all the three SKU, of course, interact together, and it's really up to you to choose. So it's really interesting because we have a lot of clients that prefer the Visual Studio extension, and then we have a lot of others that are very satisfied with reporting, and finally there are some others that are satisfied with the Azure DevOps extension. So it's really up to you how you want to work with code quality and everything NDepend can do for you.
Yeah, that's cool that there's like a command line one as well. I think I saw looking at my installation folder of NDepend. So I've got like NDepend.console, NDepend.powertools, and then the Visual Studio installer, and then Visual NDepend.exe. So
Yeah.
presume that's the standalone thing.
Yes, absolutely. Yeah.
So as an example, I personally use Rider as an IDE. So is that what I would use? Would I use the standalone tool and then just switch between them? Is that the workflow a non-Visual Studio user would?
Yes. So we don't have yet a rider extension. Actually, interestingly enough, we're talking with the JetBrains engineer to see how we can do that, because nowadays rider is quite popular among .NET developers. It won't be easy, but at the next iteration, we plan to work on this, and that won't be easy for sure. We already have a small prototype, but because the key is that Rider is a swing-based UI, and all the whole IntelliJ stuff, while NDepend is a WPF WinForm Windows UI. So there are possibility to integrate as is with WPF and WinForm UI in it. While we also have some plans to migrate the whole UI to something that can work on multi-operating system. So the thing is that we didn't decide yet what can be the the perfect framework. Could it be MOE that will come next year, or should we use something more bulletproof, more mature? So we don't know yet. But something that is very interesting is that the next version, which will be released in October, so in a month or so, will run all the reporting stuff will run on Linux and macOS.
Oh, nice, nice.
And so that was something that was awaited from a user. Yeah, and that's very interesting. The whole migration we did, because now I can say we did because now we are almost at the end, and actually the beta we have already worked very well on Linux. So basically, we had this massive legacy that was based on .NET framework, okay, with WinForm and WPF, and what we did is that we converted most of non-UI code, UI code, most of non-UI code to some .NET Standard 2.0 assemblies. So .NET Standard is like the common denominator between the .NET framework and the new .NET that used to be named .NET Core, and that is just now named .NET 5 and .NET 6. So now we have more than 70% of our code base that is .NET Standard. That's very interesting because it means that no matter the evolution of .NET, and now we know that it should be .NET 6 and .NET 7, but it can be also Blazor and stuff like that. And all this new flavor of .NET are supporting .NET Standard. And what we want to achieve is to not be a kind of trap as we were now. Like, hey, we have a massive .NET framework legacy, and suddenly the new stuff is running on Linux and macOS with the new .NET Core stuff. So we learned the lesson, and now most of our code is already running on .NET Standard, and we'll run even more of our code will run on .NET Standard later when we migrate the UI. So what we learn along the path of the large migration, because we are talking about something like 4,000 classes migrated. So that's quite a large project. So actually we used heavily NDepend as we do since the beginning. Since the beginning, we dog food NDepend. That's very rewarding to be the first user of your own product. That's really interesting.
Are you using NDepend against your NDepend project then?
Yeah, absolutely. Since the beginning, yeah. And actually, we have a lot of very strict definition of done, which is something very important for me. When do you consider it is done? And NDepend can help a lot according to us and according to our definition of done. So NDepend, because it's a tool that basically scan your code. Okay, it scans your code and it tries to infer a lot of property from it, rules and diagram and quality gate and stuff like that. What I really like is that it's objective. Okay, where typically when you do a code quality meeting in your company about your legacy, everyone is subjective. It's not my code, so it's not good, and because this one is my code, it's good. No, you need something objective in the middle of your team that say this satisfies the criteria we want. So, for example, some good criteria is let it be 100% covered by tests, okay, or let it be not complex compared to the cyclomatic complexity matrix, for example, or let's make sure that this class is not that big. Okay, so there are many rules like that, or let's make sure that the UI is not directly targeting the DB, or so that there are really literally hundreds of rules like that, default rules that you can easily customize. So yeah, so I was digressing a bit, but the key is that we dog fooding NDepend a lot. And one thing I realized, I wrote a blog post, I think it was 2 years ago, is that NDepend is very good at telling you which of your code is not .NET Standard, or which of your code doesn't abide by this. So you just give NDepend your code and a library, okay, that you want to comply with. So for example, it can be net standard or DLL, and NDepend can tell you, hey, this classes is using this method that is not in .NET Standard and things like that. Okay, so it can say this kind of stuff, and this stuff that I can say it was an accidental feature. It was not planning from the beginning, but because NDepend is very configurable and flexible, actually it's possible as is to have this kind of feature. It really helped us a lot to migrate our code. Like for example, we had some UI code entirely mixed with some non-UI code. So it really helped us say, hey, this code you're gonna put it behind an interface, then you're gonna use some kind of dependency injection to invoke it and this kind of stuff. And now I can say that we have 70% of our code that is .NET Standard, and 70% it's a measure. As I said earlier, NDepend is very based on measure, on objectivity about your code. So it's very interesting to be able to say, hey, 70% of our code is not that standard, or 80% of our code is covered by test, or 80% of the new code since the baseline is satisfies some criteria like no critical issues, or covered by test, or no dead code, etc. So here I just mentioned a feature that is very important in NDepend, which is the baseline capability. I'm sure you and people that listen to us are already using a lot of tools to kind of scan their code, like certainly ReSharper or certainly Roslyn Analyzer. And what NDepend had several things, but one thing that is really interesting is that with NDepend you have this notion of baseline. So NDepend understand, you can say typically the last release you did is the baseline, and NDepend will mostly focus on new stuff you do since the baseline, new classes, refactor classes, refactored method, etc., etc. So NDepend can focus on this new stuff. And what's very interesting is that at the beginning you said something that NDepend was kind of exhausting, because you got thousands of issues and you didn't know what you can really do. And this is where the baseline comes to play. Instead of having thousands of issues, you will just have issues on the work you are doing right now. So you can say something like, from now, we want to satisfy the good quality principle. Okay, and those are very concrete, as I can explain later. And that's very important, because this is the only way you can really improve, because NDepend targets real professional team that have legacy, that have dozens or hundreds of men years behind. With such large legacy, you cannot say, hey, we're gonna stop everything, we're gonna now live in a green field, so we're gonna spend a lot of months refactoring everything and satisfying everything, all the good principle. That's just not possible. So the only good approach is to say that from now the code we're gonna write or refactor is gonna be well done with the right principle. We're gonna write tests for it. We're gonna make sure it's not too complex, and this is where the baseline feature can really help a lot compared to other tools that are extremely useful like ReSharper and Roslyn and stuff like that. But NDepend does it differently, in the sense where you can measure your progress, and especially you can measure it on the new stuff you are doing.
Out of interest, with the baselining, how does it persist the previous ones? So, for example, if you're running this in Azure DevOps and you might have multiple build agents, where does the history of previous executions get stored?
So since the beginning, actually, NDepend doesn't work with a DB, okay, like SQL Server or whatever. It just works with it's a file system. Because since the beginning, personally, I think it's much easier to do, and it's also much easier for developer, because then they can modify very easily the file system to, if they don't want, for example, some analysis result or whatever. So it's very easy to modify. So as you understood, NDepend is doing some snapshot of your code base. So you input some projects, some solutions, or some assemblies, and then NDepend outputs concretely an independent analysis results, which concretely looks like a binary proprietary format file, okay, .nda. So we don't want the user to put their hand in it because it's very optimized. And it's like if you're putting your hand into a SQL Server file. Of course, it's not possible. So it's just a file system-based approach. And then we use some Azure DevOps artifacts. Actually, I'm not the Azure DevOps product manager, but I know they're using some artifact with it, and it just worked pretty well.
Cool, cool. I'm just thinking about other ways of doing CI/CD. So that obviously we've mentioned Azure DevOps, but there's other providers as well. And then quite often now Docker is becoming quite popular. So we can spin up and run tooling in Docker, so you don't have to install, for example, NDepends or whatever tool it is on different build agents. Does it have support for all this kind of stuff?
Yeah, sure. So here it's more about the licensing system, and yes, we have a very flexible in-house licensing capability. So all those scenarios can be addressed, and some of them require the user to come back to us, so we can tweak their license accordingly what they want. But yes, it works. We have also TeamCity extension in addition to the Azure DevOps extension, because TeamCity is quite popular. We also have a SonarQube extension in the sense that you can import all the issues and technical depth of NDepend into SonarQube. So if SonarQube is your way to handle technical depth, then you can add up NDepend in it. This was also something requested by several users. One of the difficulty of a tool like NDepend is that things are evolving constantly. For example, now people are asking about GitHub Actions, which is very popular. So we are working on it, but we're not yet there. But this is something I hope we'll have for 2022. And so yeah, one of the difficulty is the plurality of all those CI/CD system, and also now it's not only CI/CD but also the IDE, because now we have Rider, we have Visual Studio for Mac, Visual Studio Code, and stuff like that. So yeah, that's not easy, but we work hard on it.
I can imagine there's so many different ways that you can have your developer set up. And because now quite often you can mix and match in any way, shape or form. Like whether it's Rider, Visual Studio, VS Code or whatever, Vim, whatever it is, you've got different CI/CD pipelines. You've got, as you say, different operating systems. You've got people want to do things on the command line versus using a GUI. There's just so many different combinations. I can't imagine all the different feature requests that you're getting in. And even like we mentioned about the Rider extension and then the Visual Studio extension. It's not just the core functionality that you're writing, it's the GUIs like to integrate into that IDE. It just sounds like such a massive amount of work.
Yeah, that's not easy, but that's very fun. Personally, me and
that is a very good way of thinking about it. I like it.
yeah, it's good to have challenge, and also it's a way to be maybe a bit different at some other tools. So yeah, so one of the point with NDepend is that we try to be extremely fast at doing everything, analyzing, computing diagram, running the rules and stuff like that. Not only because it's good for the users, that's what the user want. Nobody this day want to wait, and we can see all the rambling on Visual Studios that sometimes slow down, and ReSharper that slow down a lot also the IDE. So we can see all this dissatisfied developer. So since the beginning, we've been very careful at having a tool that is very fast, and everything is done in a matter of seconds. Even analyzing a very large code bases. For example, it can analyze .NET 5, the entire .NET 5, into less than 15 seconds.
Wow. When I tried it on my own project, which is obviously much, much smaller than that, I was impressed with the speed, but at 15 seconds for all of .NET, wow, that is very impressive.
Yeah, that's a thing. That's a 16K types, like classes. Yeah, maybe not only classes, but also structure in the animation. That's one of my preferred thing in programming, is to have some very efficient code. Okay, and I think it reflects into NDepend. And also, What's interesting is that for smaller project, it's very good to have everything that works very quickly. But then also we have a lot of clients, a lot of large team with very large legacy. I'm talking of project with hundreds and sometimes thousands of components. And .NET 5, for example, I think it has 165 components, assemblies or project, depending on how you see things. Yeah, we really have clients with, for example, we have clients that have more than 2,000 components, and this .NET code is inside the scanner when you go to hospital. Okay, you have the scanner, and there is a massive software behind. There is tons of math in it. There is ton of UI stuff to do all to get some medical images. This one, actually, this is Siemens people. So there's Siemens scanner. They're using NDepend since the very beginning. Okay, and we are working very closely with them because they have one of the most challenging .NET code base you can imagine, and it's very interesting to be practically the only tool that can work with such a large code base. Like they need to have several studio solution, Visual Studio solution, because Visual Studio cannot open it. It's so large, and also ReSharper cannot work with it because it's so large. But NDepend can work in a 64 bits process, and maybe it takes a few minutes to analyze everything, but then they can start to have some meaningful data on their super large legacy, and for us this is very rewarding to have such a user base that I'm not sure to say in English exigeant. In French we say exigeant. They really need the best of the best because they have massive problem, a massive legacy, and this is really rewarding to be able to satisfy these people.
Yeah, I think anything in medical, code quality is so important as well. So to have a tool which just ensures that and just watches your back just sounds amazing. Are you leveraging Roslyn at all for this analysis? Or presumably you started this before Roslyn was a big thing.
Yes, absolutely. Yes, and NDepend started in 2004, and I think Roslyn was RTM in Visual Studio 2015, so it was more than a decade before. So by now, NDepend is not at all based on Roslyn. So we have our own analyzing code, and we don't use yet Roslyn, but we won't change our analyzing code that is working well and that is extremely fast. But in the future, we plan to have some bridge between our code model and the Roslyn code model. So this way, we can propose more interaction from the EDE. We can do more things later. But the key with Roslyn, what a big difference, and again, it's related to performance. A big difference between NDepend and Roslyn is that Roslyn, it does everything. Okay, 100% of any single character in your source file matter to Roslyn because it can change anything. Okay, while the NDepend is more focused on what the tool wants, so it doesn't look at everything. Okay, but it just take what it needs to do its analysis, and because it takes much less data, it doesn't need the tons of data you get in Roslyn. This is why it can be so much more faster. So, for example, you can compare the performance of the ReSharper or the Visual Studio dependency diagram, and you can see that NDepend can be 10 to 100 times faster, for example, because of this kind of reason. Because NDepend doesn't try to understand everything in your code. So concretely, NDepend is interested in dependency, of course, because its name is NDepend, and I believe dependency is really at the core of a good or a bad code base. Typically, this is why we say spaghetti code when the dependency are not at all well managed. Okay, when the code is entangling. So of course, you can extract all the dependency you can have in your code, and then all the measure you can have in your code, like the complexity, the number of methods, the number of fields, etc. Okay, it can integrate also some code coverage data. So NDepend is not a code coverage tool, but it can import code coverage data from the most popular tool like .cover, like NCrunch, like Visual Studio Coverage, etc. NCover, OpenCover, etc., etc. So you, no matter your code coverage process, you can import into NDepend your data. Okay, and then NDepend can have some very interesting rules because it knows about the complexity, it knows about the coverage, it knows about the baseline. So typically, you can ask, for example, new methods compared to baseline that are not 100% covered, for example. So you can have this kind of rule, or you can have a rule like, tell me which classes used to be 100% covered, but is not anymore 100% covered. Okay, so this is quite interesting to mix all those things. Something very important I didn't mention yet in the tool is that everything is based on a C# link queries. Okay, so on one hand, you have this code model that is the analysis result, the snapshot, where you have a modelization of assemblies, namespaces, classes, methods, fields, etc., enumeration, etc. And so you get a lot of information like dependency, complexity, etc. And then you can target this model with C# queries with some very fluent API that was designed. This is NDepend API. And everything in NDepend is based on that. For example, all the rules in NDepend is actually a small C# queries with the description as a in comments. Okay. And for example, rules like I don't want that new method being too complex can be like one if count greater than 0, which is not a non-C# prefix. And then everything after the prefix is just here to say, hey, it's a rule and we don't want any match to the query because any match will become an issue. Okay, so the query can be the prefix can be one if count greater than 0, and then you have your typical link query like from m in application method where m dot complexity higher than let's say 30. Okay, and m dot was added, which means was added since the baseline. Select m dot m comma m complexity comma m coverage comma etc etc. So this is how the whole system work, and you have around 200 of rules and query by default. It also means that it's a bit like LinkPad. Maybe you use LinkPad, which is a really cool tool. Right, you can target any kind of modelization. It can be a DB or an XML file or whatever, and then you can start to write some link query about it. And NDepend is a bit like that, except that the model is about code quality and code dependency and everything that matters in your code base. For example, you can output a metric from a query. So, for example, you can have a query that asks for issues that are critical or new issues since baseline that are critical. Okay, and from there, the results will be a list of critical issue new. And from there, you can get a scalar, which is the number of such issue. And then from there, you can start to plot this kind of scalar with time. So with time, you can have a lot of charts. So this is another feature of NDepend where you can plot chart with time and see if you can progress against the default measure. But also because it's just C# link query, it's very easy to write your rules and it's very easy to write your what we call trend metric, like a scalar metric from your code base. And we have another way, another kind of metric which is very useful, which is named quality gates. So again, you have a code query that return a list with a count or just a scalar. Okay, and from this number, which is the count or the scalar, you can say like fail if, for example, the code coverage ratio is under 80%, for example, or one if the number of critical issues is above 30, for example. Or you have also the quantification of technical debt, which manager likes a lot. So basically, the technical debt is the amount of work to fix the issues found. Okay, so NDepend is very strict about that, and there's a lot of smart estimation about the technical debt. So you can have some quality gate about I don't want that compared to the baseline, we introduce more than 10 human day of technical debt. Okay, so this is interesting because not only from the beginning NDepend has tons of queries and rules and quality gate and stuff like that, but they are extremely easy to customize because it's just C# link query. So basically, you just open the NDepend editor, you edit them, you get the results in real time because it's very fast. And then when you satisfy, you just click save, and then you can really parameterize everything you want, everything that matters to you. You really own definition of done. Okay, you can parameterize it, and then you get a tool that is totally adapted to how you like to work and how you like to get things done.
Cool. So we covered an awful lot of stuff there, but going back to the link, like you're saying that everything's written in link. So if you've got like a custom rule where you've got some link, is that stored in your project, which you can put in source control alongside your project?
Yes, absolutely. Yeah. What's interesting is that it's textual only. So there is no project, no Visual Studio project, no assemblies to deal with. There is nothing. NDepend is able to take your textual query, compile it, and run it. Or if you have compilation error, it will tell you. And if you have some warning, it will tell you, of course. But it's only textual. Typically, you can store your rules into your project, and you can attach your project, your NDepend project, which is .ndproj file, which is just XML with a CC data formatting inside. So it's very easy to even edit rules with the source file with Vim or Notepad or whatever. And also you can have some rule file that you can share among projects. So we have a lot of users that have a lot of projects. Again, so I'm referring to these guys with a massive legacy, and legacies are plural. They are just not one legacy, but many. So they like to have some kind of enterprise constraints, okay, so rules, so you can share it among a file. So this is one thing very interesting. And again, it's very fast. So to give you an idea, it can compile around 200 queries in less than a second. And on a large enough code base, the queries will take less than 5 seconds to pass all queries. So you can get all your issue, all your new issue compared to code base, and all your code base, your technical debt estimation. Also, all of that you can get it in Visual Studio or in the standalone in just a few seconds. Compared to the other tool that are extremely good at analyzing the file that you are currently editing, which is absolutely great. But if you want a more 100 feet view of things, then it will take very time. For example, in ReSharper, you have this mode where you can get all the issues, but I think if you do that on NDepend, it takes more than an hour to go through everything and try to give you something. So yeah, I believe this is important to be fast with this kind of approach.
Yeah, definitely. It's the whole developer cycle, isn't it? Where you want that really quick feedback loop as you're coding.
This is very important, yeah. This is, and more important, yeah.
So it's interesting you mentioned LinkPad before, because you mentioned it when you were talking about NDepend's generating link. I found that this is a bit of a tangent, but when I was using it, I pressed Control-Shift-F to find something within all my LinkPad scripts, and it created the new query, which was link, to do the find. So it sounds very similar to what you're doing, where you actually, the user of NDepend can actually modify the link you generate.
Yeah, and actually the tool were created around at the same time in the around 2007, something like that. So actually Link was out in 2008. So NDepend was Link friendly in 2010, and iPad just came just after Link as well. So, but at a point Microsoft said now all the query things will be Link, and actually at that time we already have our own custom query language that looked like SQL, okay, and but that was much less powerful than Link, of course. Who can be as powerful? You cannot do something as powerful as Link. So now that's very interesting because Link is so powerful that, and all of our users that are C# developer, typically they know Link, so they can play with the tool. But we also generate a lot of queries. Just to give you an example, you have NDepend into your Visual Studio. You have this large project that you want to look at the architecture inside because it looks like untangled, like most of large projects actually. So you just go to your solution explorer, you right click your project, And then with NDepend, you get a menu which says show me on the dependency graph. So you just click that, and what happened under the hood is that NDepend will generate a code query to format everything interesting you have into your project, all the namespaces, all the classes, everything that is worth being shown. It edit the query compile and run, then you get the results, and then NDepend grab the results and print it onto the graph. And everything I'm saying is typically take less than a second. Okay, so it's very quick. But then not only you get a graph of exactly what you wanted, but also on your side you have a code query that you can edit and refine. So maybe you want to just look at some of the namespace into your assemblies. So it's very easy to go to the query and then refine it and then export the results to the graph to typically see exactly what you want, what you are interested in.
The first time you use NDepend, like so you open up Visual Studio or the standalone application and you analyze your project. So you create a new NDepend project. So when I tried this on one of my projects earlier this week, so obviously the rule set is giving you a to-do list effectively. So that's really easy to look at and know what to do mostly. But with the dependency diagram, what would you recommend is the best way? So if a developer, the first time they're opening up an existing legacy project, they get a big, massive dependency graph showing lots and lots of things. How would you recommend that they look at that and mentally try and process that and decide how they can improve? Do you have any general recommendations?
Yeah, sure. So this is the actionability. So from what we know, as you understood, we work very hard on the speed and on the UI. But NDepend deals with a lot of concepts that are not necessarily easy for every developer. Okay, and sometimes some users say, I'm a bit overwhelmed with everything. So the first suggestion would be just to abide by the baseline. So you do your first analysis, and then you don't really look so much. You can play a bit with what is said. Then you develop during 1 day or two, and then you see the difference between the baseline, and then you can learn from NDepend why NDepend is hitting these issues on my new code and my refactor code, because this is code you just wrote yourself. It's very fresh in your mind. So it's really an effective way to get started with NDepend is to not being, okay, today I'm going to start with NDepend during 3 hours. I would more suggest like do a first analysis, have a little look at it, and then let the tool analyze your diff, okay, the work you're doing right now, and let's see what it can say. When it comes to the dependency graph, so this is a feature, we worked a lot on it. It's very important, and it can does a lot for you. But the most actionable things typically is trying to get rid of spaghetti code. What is a spaghetti code? Typically, one core principle when you do code is to separate things into modules. And this module, typically, you call it components. The thing is that in .NET, there is nothing physical that looks like a component or a module. You have assemblies. Assemblies are physical files. Then you have namespaces inside assemblies. So namespaces, they are a logical way to organize your code. So they can be used both as an API presentation to segregate your API into several namespaces, but the namespaces can also be used as a way to have logical components into your assemblies. Because I don't recommend considering your assemblies as your component. It's much better to have large assembly with well organized namespace in it. And then you have the class, and typically a class, it's too small and too shallow to be a component itself, okay, or a module itself. Typically, you have a group of class of interfaces of enumeration that you put into their namespace, and you say this namespace is my component, because each class has a responsibility into the component or each interface also. And here we are typically in the solid concept. And then you pack everything into a namespace. And then you have your assembly with 10 or hundreds namespaces that interact together. And this is how, in my opinion, at least you can have a good software with good componentization. So when you open the dependency diagram of your application, typically you have several projects, okay, and inside each project you have assembly. So the good thing is that there cannot be dependency cycle between projects. Okay, Visual Studio prevents that, and MS Build also prevent that. So always have a low level project, and then some higher level, and then some very high level. And typically, the low level project is made of interface. If you are good at following the SOE principle, so this way you are not sharing implementation between projects, but you are sharing abstractions. And then typically you have some domain above that, one or several domains. Then above domains, you have some infrastructure that can be web server, that can be UI, that can be DB, whatever. So typically your project are layered like that. So the first thing to do is because now you have a mean to visualize everything. You have a nice dependency graph. First, you can verify with your eyes into the dependency diagram that you have this kind of architecture. Nowadays, there is people are claiming about clean architecture, which is a very interesting movement. Again, this is Mr. Uncle Bob that coined it. Okay, he wrote a book about that. So typically, you want to have interface low layer, then you want to have your domain. Okay, and your domain, that's very important that it's only POCO object. POCO, this is plain old CLA object, which means that you can depend on like things like strings, integers, and really primitive tips like that. Okay, but you're not supposed to do in your domain file access or DB access or web access or UI access or all this stuff that are named like infrastructure. So you can check that your domain assemblies are not accessing all those things. And actually, with NDepend, it's very easy to write this kind of rule. You can very easily write some rules like, here is my domain. I don't want my domain to use anything like, for example, system.io or system.winform or webform or whatever, isp.co or whatever. Okay, so it's very easy to have rules to first visualize that your domain, you have a clean architecture first, and second, it's easy to enforce what you see or what you want. And you can also write some rules and then your custom rule for that, and then fix all the issues that you have in this rule until you are very satisfied with your architecture. Okay. Another point you want to use the dependency diagram for is to disentangle your code base. So here, what you're gonna do is you're gonna have a look at which components are dependent among each other. Typically, you want a well-layered diagram of that. So NDepend can help you because it has a color system. And when everything depends on everything, it has several features to tell you that. For example, you have a button named cycles. So if you click this button, another code query is edited, and this code query is listing all your assemblies, and in each assemblies, it's listing all the dependency cycle between namespaces. And then you can export each cycle to the diagram, okay, and you can immediately identify what code is very entangled and what you can do to disentangle, because in the same query edited, you have some advices about what to do to disentangle. So those are some usage of the dependency graph. And then there are usage across during your development. So typically it's when you are, for example, touching a very low level classes, you want to interface, you want to know everything that depends on it into a call diagram. Okay, so with NDepend, you can obtain such diagram in one click. Okay, you have many kind of diagram like this one. So for example, you have two projects and you want to know for A is using B, and you want to know what from A is using what from B, for example. So again, so A is using B, you can see that on the graph as an edge. You just double click the edge and immediately you get everything from A that is using everything from B, and you can get a diagram from that. So yeah, there are many usage of the dependency graph because again, as I said before, dependency is something very important into code bases, into software development.
Yeah, I can imagine this being such a good tool for a team doing a mob session where you've got the team in a room together looking at these and just asking questions. Why is that component talking to that component? And really trying to discuss and like having these diagrams to actually open up the discussion among the teams. I can imagine that being so powerful.
Yeah, and also, for example, because everything is quantified, like technical depth and complexity, code coverage, etc. Everything is quantified and queryable. You can start thinking of how much depth we have in this component, and because it's objective, we can propose to our manager, hey, look at all this depth. For a long time, we said you that this component was a big problem for us, and I think this is a very true situation for a lot of team. Okay, and then you can go to your manager and hey, now we want to get rid of it because look at that and NDepend estimate that it's really not good and we want to change things. So it can be a tool also to for manager, for team leader, or for developer that want to convince fellow developer or manager. So it can be used also in that.
One of the features I saw on your website in the list of use cases was about detecting API breaking changes, which sounds really interesting. So is that automatically anything you do that's going to affect the outside interface, like the request and response DTOs, the actual route, the URL, anything like that? It'll just tell you that something's like you've changed the outside, the public interface.
Yeah, when NDepend get started, like more than a decade ago, this was this kind of free accidental feature we got. This is not a feature we necessarily think about it, but suddenly we realize, hey, we have everything. We just need to write a few rules and we get the features. So a lot of feature, what was very tough was the analyzing system, the code model, the link stuff. But then from there, this is why NDepend can do so many things because it has everything. It knows very well your code base and also your code base evolution since the baseline, diff since the baseline. So typically what happened at that time, look at that. We know which class used to be, for example, public or which interface used to be public, which method used to be public. And because we have a diff since the baseline, we are able to know if a public class become internal or private, for example, or we can say, hey, this interface used to have 10 methods and now it have only 8 methods, which means that if some of your clients are implementing it, they got broken. Okay, so because we get all this detailed data, it was very easy actually to write some rules, some default rules that you get out of the box. Okay, it was very easy to write this kind of rules to detect typically the API breaking changes. And again, for example, I was referring to the Siemens team with tons of legacy, and I can say they are very strict. They have so many developers that they have to be extremely strict in terms of contract, in terms of API, because they really need to modularize things because the legacy is so big. So I can say that one of the major interests is to make sure that they are not breaking the API they are using to talk between each other, because that's very important for them.
I love hearing stories of accidental features that turn into big features just because
Yeah.
just because of the way it was built in the first place. So if NDepend does detect that you've made a breaking change, can that be hooked into however you do versioning? So for example, maybe using Git version to do your versioning and semantic versioning. Can NDepend then tell that to increment the major version, for example? Or would it always just be a failure? Something's broken, so the build's going to fail. Is that how it would work?
For now, unfortunately, we are not Git integrating, as I said earlier. So for now, it works side by side with Git, but you can manage very easily your versioning with NDepend because it's just a file system. So it's very easy to share with other developer. It's a very easy to adapt it to exactly what you want. One thing compared to Git is that NDepend understand more about your code in the sense that because the primary source of analysis is your compiled code, okay, but also NDepend analyze source code, code coverage, etc. NDepend can distinguish in changes when he does diff into our model, because we have a model for a code base, but we also have a model for the diff. And into the model for the diff since the baseline, NDepend can make a difference between a code behavior change. For example, you had a method and you're changing its body, then it's a change. It can differ that with a formatting change. For example, you introduce some space or you're reformatting your code. So for Git, it's a change, formatting change, or behavior change is the same. Or maybe you can add some comments. So NDepend can detect it's a comment change and not a behavior change. And this is very practical because then you can change some formatting or some comments, but NDepend will still see that the behavior is the same. And the behavior is king, right? It's very important. So you can treat differently a behavior change with just a formatting change, which I believe is very important because typically if a method didn't change since it's in production, since the last release, if it's working well in this release, you can add comment or change it, etc. But then in the next release, it will work well also because it actually didn't change. The behavior is still exactly the same. So this is one interesting thing. Some other changes you can spot is a visibility change. For example, a public method became private, for example, or documentation change and stuff like that. So yeah, that's we're not yet that we are totally integrated with Git, but on the other hand, you can have some interesting stuff to do, and it has also this trending database that it maintains, which again is just a file actually physically, but trending is, remember, is just plotting. You have some special query that are here to output a scalar, and then you can do some charting to follow the evolution of your code base. For example, the evolution of your code coverage or the number of classes, the number of defects, etc., etc. So earlier you were mentioning the build failure, which is something very important because nowadays everybody has a CCD, and everyone want to be warned when something is going wrong. So typically, this is why you are writing a unit test. This is why you want them to fail when there is a regression or a new bug or stuff like that. And NDepend works the same, like it have all these rules, and you want to fail upon some condition. The condition is not necessarily I don't want any issue or any new issue. NDepend can be much smarter than that, thanks to the notion of quality gate. So as explained earlier, quality gate is just a C# link query on a particular aspect of your code base. It can be code coverage, it can be number of issues, the severity of issues, it can be technical debt, like amount of technical debt, and again, everything can be restricted against the baseline. So typically you can write, I don't want more than 10 human days of work of technical debt since the baseline. And it's very easy to take the existing quality gate and to adapt them. Okay. And this way you can really define your own definition of done. Personally, I like to be done when all my class are 100% covered, except when the UI class that are very hard to cover. But apart that, 86% of the whole independent code base is covered by tests. And this is very important with all the assertion also. Like we put assertion everywhere, not only in tests, but also in code. Okay, when we run our test in 26 minutes, there are more than 16 millions of assertion that are executed. So that's a lot of assertion, both in test and in code, that can really verify that we don't introduce new bug and new regression. Okay, and then you can have some quality gates about all those stuff that can tell you, hey, we are not good here, and we are not done. We are not done because of your very own reason. So I think it's important to let the user customize its own definition of done, because from what I've seen, we all have a different way to consider done. Some typically it's very shallow, like, okay, the code works, we done, we can release. But if you are serious, you don't want any regression, you want to have all your tests and coverage and stuff like that. So NDepend can be very good at helping with that.
Yeah, we could have a whole episode on definition of done and what should be in it, because I've seen all ranges from as long as you've pushed to Git, then even before CI/CD deploys, right, we're going to mark this Jira ticket as done. And it's like, no, you've got to actually test it before you do anything, at least. But yeah, that could be a whole episode. So shall we do dev tips?
Oh yeah, sure. Yeah. I have a few. So one thing, so I mentioned earlier that NDepend will run on Linux and macOS because most of our code is .NET Standard, which means that the exact same binary can work into a .NET Framework process or into a .NET 5 or 6 process, which is very cool. Something that helps a lot to develop that and to test that was to use the Windows subsystem Linux, okay, WSL, okay, which is now in version 2, which is already quite mature. And it was extremely convenient to because simply because it avoid having to switch back and forth like a virtual machine or Linux virtual machine or maybe another machine or whatever. Actually, with WSL, you really have a full Linux as an application into your Windows system. Okay, so is already pretty cool. But what is even cooler is that Visual Studio is aware of WSL, which means that when you hit the F5 debug button, it's gonna debug into Linux your application. So it's really marvelous to test all your application into Linux. It's extremely productive and it was really helpful for us. So it's not so easy to get started with. It's not at all very complex. But what I do when I spend time on a technology like this one, until I really fully master it to get the most of it, I write a blog post with all the caveats I got from it. For example, one caveat I can say is that your PDB file must be compiled as portable. Okay, because if they are not portable, they're not going to work on Linux. So you must first ensure that your PDB file is portable. So there are many warning and advices to work with WSL like this one. So I put them all into a recent blog post on the NDepend website. And I like also to share that with me later and also with the team. So everyone is on the same page. Okay, so I wrote a detailed post about that, and it was a few weeks ago, and I think it received a lot of view, and people were quite happy with it because it contains a lot of advices on it. So if you are careful about migrating or working with Linux and .NET in Linux, maybe, and you still like your Windows, developing on Mac, for example, then you can use WSL and get all the tips from the blog post.
Yeah, WSL2 is really, really nice now. We actually had on episode 7, Stuart Leeks joining us talking about WSL and dev containers. So all this kind of thing where you can just use VS Code and spin up all your dev environment and shared config like you're describing just within containers. And it's not really a workflow that I've properly played with yet, but I would really want to start playing around with like dev containers and all this kind of stuff. I use WSL2 from time to time, but mostly it's just for Docker stuff rather than like dev containers and all that kind of stuff. But yeah, it's definitely really interesting seeing the interaction between Windows and Linux, like Linux now with WSL2. So my dev tip it's just a quick productivity tip about using virtual desktops. This is just something I've started doing more recently to separate out what I'm working on from other stuff. So it just helps me keep focused and less distracted. So it's the old out of sight, out of mind thing where I'm keeping things like email, Twitter, Slack, whatever, just completely in another virtual desktop. So it's just, I can't see it. Now, obviously I could close those things too, but I just find using virtual desktops is a nice way of not having to close everything, but keeping things separate and hiding them away. It just helps me keep more focused on what I should be working on.
Yeah, to be in the flow, which is the most precious asset a developer can have is to have a routine, to end up in flow for an hour and two and be super productive during that flow. And this is why performance matter much, because if your compilation process is taking 15 seconds, during that 15 seconds, you want to flip on the social media or prepare a coffee or whatever, and you just break your flow, and that's why the speed is extremely important.
Yeah, exactly. You mentioned at the start all the cool things that are coming to .NET 6 in November. One I'm really looking forward to is the hot reload functionality, where as soon as you save something, if it's a website you're doing or a mobile app or whatever it is, boom, it's just updated straight away.
Yeah.
And just cutting down that developer flow. So as you say, even 15 seconds is enough to make your brain wander off to social media or something.
Yeah, absolutely. Oh yes, 15 seconds is really bad. Yeah, you have personally because now NDepend is, as you understood, it's a quite a large project. So what we do is that we have some smaller solutions when we want to just work on the domain, on the core, on the query system, on the what. So just to have a much less progress project. So this way the compilation is normally Visual Studio is supposed to understand when it doesn't have to compile an assembly, but it doesn't work as good as I would like. So it's important to focus on a very few projects to just make sure that you get the best performance and that you don't lose your time, because that's at the end of the day that's really that what makes a difference if you want to go to have a jogging or spend some time with your kids or whatever. At the end of the day, that can make a large difference to have this, to be very careful with your development environment and to make it sure it will be as fast as possible.
Yeah, definitely. Time is a resource you can't get back once you've spent it.
Yeah, absolutely.
So before we wrap up, what's the best way for our listeners to get in touch with you if they have any questions or anything?
Yeah, sure. Just Patrick with a CK at ndepend.com. And that's my direct mail address. And if you want to play with the product, just go to ndepend.com. You have a download free trial, full featured. Okay, 14 days with extra 14 days if needed. Okay, so you can in 5 minutes. Typically, in 5 minutes, you can have an NDepend installed already that already analyzed your code and that already try to give you some advices about it. He try to shed light some stuff. So typically in 5 minutes, there is no complex installation. It's just a zip file. You just unzip it somewhere. There is no registry or complex installation or even have to go to an administrator or whatever. So it's very straightforward. It's just exactly like you want to run your own assemblies. Okay, you just speed it somewhere in your hard drive, just run it, and typically in a few minutes, it's very lightweight. It's only 18 megabytes, and the next version will be only 14 megabytes. We like to do more with less. And typically, the community call it the Swiss Army knife for developer. So as you understood, there are many features. So you can just imagine which feature you need to improve, and certainly you will find it in NDepend. And you can refer to our use case page, and you have like 20 use cases to see which one suits you best to get started, and then make the tool actionable from the beginning and make the most of it.
Fantastic. Okay, so a big, massive thank you for joining us. It's been really great having you on, and I really need to go away and play a bit more with NDepend now, and just like run it on more projects, and then start crying as I see how bad my code actually is.
Thanks very much, Dan, for the podcast. It was a very good moment.
No problem. And thank you everyone for listening. A quick reminder that this podcast is sponsored by Everstack, which is my own company providing software development and consultation services. For more information, visit everstack.com. And if you're enjoying the podcast, please do help me spread the word on social media. I normally use the hashtag #unhandledexception, and I can be found on Twitter at Dracan, DRACAN, and my DMs are open. And my blog, danclock.com, has links to all my social stuff too. And of course, we will include links to all the things we've mentioned today in the show notes, which can be found on unhandledexceptionpodcast.com.